Welcome back to Workshop Wasteland. If this is your first time stopping by, go ahead and check out the channel. This is part 5 of a 6-cycle oddball build series. If this is not your first time here, welcome back. Thanks for stopping by once again. In today's video, we are going to be taking a piece of metal that looks something like this and turning it into a flywheel that looks similar to this. Also, I'm going to mount the cylinder and drill and tap those holes. So I guess let's hop over to the lathe and get cranking on this flywheel. The first order of operations is going to be lightly face off this face of the flywheel. Then we're going to switch it around in the chuck and do the same thing to the other side. Always a good idea to get that stringy mess out of the way before it flies up and hits you in the face. Ideally you wouldn't end up with that, but tool left kind of a crappy surface finish, but I think that'll be just okay. Flip this around. Tap that in real good to the chuck because we want this to end up with 2 parallel sides. So that's why I went through all that trouble to do that. Now we got to cut a bunch of material out. And one thing that a lathe really sucks at doing is plunging into the face of a part. So I'm probably going to play some music over this. It's going to be a lot of chatter, a lot of squeaking. And there's just no real great way to go about doing this. At least I don't know of a great way to go about doing it, but it's necessary in this case, so we're going to have to do it anyways. But like I said, it does a lot of chattering, a lot of carrying on, so unfortunately I don't want it to be super annoying and noisy, so I'll most likely time-lapse a lot of this and play some music over the top. So I guess enjoy some machining and some cool tunes. So I forgot to mark this where I was going to start that taper in. So I'm going to mark that real quick. So what that did was basically gave me a don't cut to that line because we have to cut a 45-degree taper in there. So a little bit of checks and balances along the way. Alright, so that's what we end up with for roughing that part in. Roughing it in being the key here. Now we can come along with this boring bar and clean this up a bit. Alright, I'm going to finish roughing this in, and then I'm going to let it cool down so I can get accurate measurements, and I'll bring you back when it's time to cut the 45-degree taper in here and bore the hole in the center. Alright, got myself all set up here. We got this center diameter turned down. Now I'm cutting this 45-degree angle, and to do that I'm using the compound, which is set at 45 degrees. So we can come in and get that cut to the mark and be basically done on the lathe with this part. I also, as you can see in the video, the bottom's pretty rough right now. It's not to dimension yet. I think I have to take about 5/10 thou out of it. So let's continue on with what we were doing here. I think I'm going to try speeding this up a little bit for chip management. See how that does. Still making some stringy chips, but that's alright. We'll suffer through it and get it done. Alright, so you can see we're getting this taper cut in here, and we have to come all the way over to the line that's scribed on there. So I'm going to get this finished up and show you the next operation. Just wanted to kind of show you the setup here. So from the face, which is where my tool is touching right now, we need to carve this down 250, a quarter of an inch. So I got my hard stop set against the carriage right now, and it's at 410. So 410 plus 250 is 660. So if we run this out to 660, and then lock it with the little lock, now when we crank in on the part and we come in, you can see the tool's touching there. Probably can't quite see it in the video, but there's a bit of a gap, so that's how much I left. That's how much material needs to be taken out yet to smooth out the bottom and make that look real nice. Just thought I'd kind of show you how you can use this micrometer as a hard stop that's like adjustable, and I really actually like using it. Alright, pretty much the last thing that we have to do here in the lathe is bore a 5/16 hole in the center of this for the axle, crankshaft, whatever you want to call it. So we'll use a center drill first here. Then we'll step up through a few drill sizes. This is a letter N drill, which is slightly undersized, 5/16. I think my small boring bar will reach in there. Don't remember. What we're going to do is take like 1/1000th out with this boring bar, and that should ensure that the hole is very concentric before we use the reamer. So all that did was made sure that whenever we put this reamer in, it's actually reaming, let's say, in the center of the part. Alright, so I slowed the lathe way down because sometimes reamers are a little bit grabby, and the last thing I want to do is break this off, because they're not really too cheap. So let's go ahead and slowly cram this reamer through. And like I said, I bored the hole with the boring bar, so it should be nice and concentric, and this shouldn't cut much out. Alright, perfect. Easy peasy Japanesey, as they say. So that's it on the lathe for now. We have to drill a hole in the center of these, and then I want to clean off the outer edge, get rid of the mill scale and all the ugliness of it, but that's all we can do for right now. So I'm going to switch over to the milling machine to get this basically finished. Got these two flywheels clamped down over here in the mill. What I did was put this piece right here in my drill chuck. Move that down so you can see it. I put that in the drill chuck and zeroed my DRO and clamped these down, and then I have to ream a 5/16 hole 13/16 from the center. So I'm going to go ahead and get that underway now. This is a spotting drill that's extended out pretty far. I hope it doesn't want to wander. I think that did just fine. Go ahead and swap out this bit. Like I said, that was just a spotting drill. Get a little bit of cutting oil for this, since it is steel after all. I need to be a little bit careful coming through the bottom, because I don't want to drill into my table. So that was a 1/4 inch. So 5/16 is 312. This is a letter N drill, which is 302, so that'll get us pretty close. Alright, hit this with a 5/16 reamer. Alright, now I need to determine if I'm going to drill the 2 holes through here like the plans call for, or what I want to do exactly there for the balancing holes. Alright, got this set up over here in the drill press. This plate is just sitting here right now, but the center of this that we bored keeps it aligned. So what I'm going to do is use the same drill as a spotting drill that I used to drill these holes, which was a number 29, and just use it as a spotting drill to make a little dimple in this. Looks like that worked perfect. Now we'll put the tap drill size in for a 632, which is what the plans call for. Take this over to my little tapping fixture and show you how good that works. Well, I'm an idiot and forgot to hit record when I was tapping it, so I'm going to drill these and then I'll show you how to tap it on one of these holes. So I'm going to deburr these real good first, make a little bit of a chamfer which helps the tap start. Give them all a little squirt of anchor lube. And just like that, we got a nice tapped thread. Now, if we did our job correctly, this will fit right on here with 4 screws. Well, I had a fourth screw. Seems to have gotten misplaced, but I'll find it. Either way, that threads together like it's intended, which is just great. And you end up with something like that, mounted the way it's supposed to be. Well, anyways, there it is. Part 5 of this 6-cycle oddball engine build. Hopefully you enjoyed the video. Here are the plans for the flywheels. As you can see, there are 2 7/16 holes for counterbalance. And Mr. Joe Higgins, instead of drilling those holes, like machined a radius pocket in them. I was gonna do that, but I broke the stepper motor driver. I guess I burnt it up somehow for my rotary table, so I need to get that fixed. I'll make a video about that, and then we'll get these thrown onto the rotary table and get that pocket cut. I like that idea because it's kind of hidden, but it still serves the same purpose. So we got the 2 flywheels done. We got the cylinder mounted onto the frame, and turned out pretty darn good. So as always, thanks for watching. Appreciate you sticking around. Sorry for a few mistakes along the way, and a good bit of time lapse and playing music over the top. It's just annoying to listen to a lathe screeching and carrying on whenever you're cutting, especially cutting into the face of a part like that. If anybody knows a way to do that better, please by all means share it, but from my understanding, it's just not something that works well on a lathe. So either way, we got it done. Thanks for sticking around, and look forward to showing you part 6 next week.